Hello everybody, welcome back to rkphysicsshiksha. In this video, let us discuss a question which has come in NEET 2024. And the question is, a tightly wound 100-turn coil of radius 10 cm carries a current of 7 ampere. The magnitude of the magnetic field at the center of the coil is. So, in general, we might have calculated the magnetic field at any point on the axis of the circular loop. Means, for example, if you take a current carrying loop of n number of turns, and this is a center, and this coil is of radius, let us assume this is r, and at a point on the axis of this current carrying coil we have the point P, which is located at a distance x. So due to this current in this coil, we calculated the magnetic field at the point P, and that magnetic field at this point P is given by magnetic field B is equal to mu naught by 4 pi into 2 pi n into I a square divided by x square plus, sorry, I've taken the radius as a square. Let us consider, we have considered it as r square, so let us consider it as r square into x square plus r square whole to the power of 3 by 2. This is the relation that we have for the field at an axial point P, which is at a distance of x from the center of the coil. Now, in this case, if there are n number of turns, where n represents the number of turns in the coil, and here we have these cancelled out, and also they are asking us to calculate the field not at the axial point at a distance x. Instead, we are supposed to calculate at the center of this coil. So, at the center of the current carrying coil, for x is equal to 0, what will we get is B is equal to mu naught into ni r square whole divided by 2 into x will become 0, so it will become r square whole to the power of 3 by 2, where root and square gets cancelled out. So B is equal to mu naught ni r square divided by 2 into r cube. Now r square here and cube gets cancelled out. So what we remain is with mu naught ni divided by 2 into r. So this is the relation that we'll have for the calculation of the magnitude of the magnetic field at the center of a current carrying coil of n turns. So here from the question, what we have is, we are provided with mu naught is equal to 4 pi into 10 to the power of minus 7, and radius r is equal to 10 centimeters they gave, converted into meters as 10 into 10 to the power of minus 2 meters, which gives me 0.1 meters. So, and also current I is equal to 7 ampere, and the number of turns n is equal to 100 is what is provided in the question. Substituting all these values in the above equation, we get B is equal to 4 pi into 10 to the power of minus 7 into 100 multiplied 7 divided by 2 into 0.1. So B is equal to 4 into 3.14 into 7 into 10 to the power of minus 5 divided by 0.2. After simplifying this, what we will get is somewhere around 4 point something we will get. For example, we will get around 4 point, if we simplify it also, 4 into 3.14 into 7, which gives us 87.92 divided by 0.2 will give us 439.6. That will be magnetic field 439.6 into 10 to the power of minus 5 which is equal to 4.396 into 10 to the power of minus 3, which is equal to 4.396 milli Tesla. So this is the magnitude of the magnetic field at the center of this current carrying coil of n turns, n number 100 turns. So if you go to the options we have here, 4.4 millitesla is the, which is the closest value, 396. So the answer will be 4.4 millitesla. For more such videos, please do like, share, and subscribe our channel. Thank you.